Hello guys, this is Paul McWhorter with TopTechBoy.com coming to you today from the mighty River Nile. And I'm here today with episode number 3 in our incredible new tutorial series where you're going to learn how to make Python and Arduino work together. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, take a look down in the link there, down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. Now, last week what we did is we got our Python environment configured so that we can come in and start writing the Python code and getting Python and Arduino working together. So if you haven't done that already, make sure to go back to lesson number 2 and do that. And then today what we're going to do is we're going to make our first program where we write a program in Arduino to make Arduino do something and then pass that data from Arduino over to Python and then do some simple something in Python like print. Now in the end we'll be doing some really cool stuff on the Arduino and passing the data over and then animating it with some really cool animations. But today we're just going to take that first step. How do we get data from Arduino over to Python? Okay, are you guys ready to go? I hope you are. So let me move over here to my screen view. Let me get out of your way. And then I need you guys to go ahead and fire up your Arduino IDE. And so I'm going to get one going here. And I'm going to go ahead and make this nice and big so you can see it. Sorry I didn't have this big to begin with. But then we're just going to start by writing a very simple program that will just generate some very simple data. And then what we are going to do is we're going to then pass that data over to Python. So we're going to take the data in Arduino. Arduino is going to pass it. Python's going to grab it, and then Python is going to display it. And so really this is a very important lesson because this is just the very core, the very foundation of what we're trying to do, which is to pass data from Arduino to Python. And so we have our new slick bare minimum set up here, and so we are ready to code. Got to warn you guys, I have not coded in Arduino in about a year. I've been coding in Python, so I might forget a semicolon here and there, and I might forget to declare my variables, but we'll get it all figured out. Okay, what I want to do is I want to make a simple counter, and so we're going to come up here and be good boys and girls and declare our variables. And so I'm just going to make an int, which is count. I'm going to set it equal to 1 to start with. Don't forget your friend, Mr. Semicolon. And then I'm going to have a delay in here, so I'm just going to call it DL, DL, and let's set that to 1,000 milliseconds. Okay, that looks good. Now we're going to come down in our void setup, and what we're going to do is we're going to need to start our serial monitor. So we're going to do a serial.begin. This should be very familiar to you. We're going to live a little dangerously. 9600 has always kind of been the go-to baud rate, but we're going to go on up to a 115-200 just because we can. And then we'll put in our semicolon there. And so now what we're going to do in our void loop is we're just going to count. Okay, we are just going to count. And then what I am going to do is I am going to do a serial.print. Excuse me. I'm going to go ahead and do a print ln. What am I going to print? Count. Okay. And then let's go ahead and make it a little bit more interesting. And so I'm going to serial print count. Okay, serial print count, and then I am going to serial.print ln, so this will send it to a new line, and I'm going to serial print ln, and then we are going to count in Mississippi's. Okay. How many of you growing up learned to count in Mississippis? 1 Mississippi, 2 Mississippi, 3 Mississippis. Now here in Africa, they count in Tanzanias. It's 1 Tanzania, 2 Tanzania, 3 Tanzania. Leave a comment down below. How did you learn to count young? Did you do anything silly like 1 Mississippi, 2 Mississippi, or was that just a Southern thing? All right. So now with this, could it really be that simple? Could it really be that simple? Well, let's run this. Now, one thing I will remind you is you need to come in and make sure you're right on the right COM port. You notice that I am on COM 3. You'll be on COM something else, but you got to make sure that you're hooked up to the right COM port with your Arduino. Also, I should show you that I will be sporting today the most excellent SparkFun Red Board with the little attached breadboard. That's a live view, so you're going to be able to see a live view of my Arduino while you're able to see my code window. Now, I know you're saying, hey, I thought you said to use the Arduino, the Super Starter Kit from Elegoo. Yes, I'm using the components from the Elegoo Super Starter Kit, but the Arduino itself, I'm just using the Red Board. It's absolutely identical in every way to the Arduino that comes in the Super Starter Kit. Then you say, why are you using this? Well, I think the red just looks a little bit sharper than the black one, so I really like the red. The second thing I like is that as I'm doing a build and filming, I like that the breadboard is kind of glued down on the same base as the Arduino, so it'll keep things a little more stable as I'm filming for my build. Okay, those are the reasons I'm telling you that I'm doing this. But the real reason, do you want to know the real reason that I'm using the red board? I got all the way over here to Africa, and in all my stuff that I moved over, let's see, where can you see this? I did not bring one of those little types of USB cables. Okay, I didn't get over here with that kind of larger size USB cable. I got over here with a medium-sized cable and lots of small cables, but in going through all of my stuff, I actually can't hook to that Arduino. But it's okay, because for the other reasons, this red board will really work. And as far as coding goes, indeed, it really is identical. Enough of this chit chat. Let's jump in and let's see if this program will run. Now, we are going to return to our earlier most excellent tradition of holding our breath while we compile our code. Got to save it. All right, so I will call this, I think I'll call this pass 1, just like I did there. Let's see, will that work? Okay. Now that didn't work. I'm sorry. I've just installed this here, and so plus I've always found this just to be a little bit awkward. Okay, so I'm going to erase this one. Okay, and then I'm going to save this as pass data 1. I always find it kind of awkward how it wants to put it inside of a folder and all that kind of stuff. All right, so now it's called pass data 1. It looks like things are happy. We will all hold our breath together so this will work. It looks like it worked. Okay, so is it doing anything? Well, to see if it's doing anything, let's fire up our serial monitor, and then it should start over here. Now make sure that you're set on the same baud rate here as you set over here. Yeah, you guys can see that. Let me move it over there. It's stuck on 1 Mississippi. Why is it not incrementing? It's not doing what I want. Well, it's not doing what I want, but it's doing what? Exactly what I told it. And what did I forget to do? I forgot to increment my counter. So count is equal to count plus 1. Don't forget the semicolon. All right, now let's download this thing again and see if it's going to work. Okay. Okay, now let's open up our serial monitor and let's see if this thing is working. Oh, wow, that is going really fast. Okay, so what we need to do with that is we need to put a delay in. And we set up delay, but we didn't apply it. So let's say delay, and how much do we want to delay by DL? All right, and then our semicolon. And now we're going to download this thing. People get so mad when I say download instead of upload. It's just in my mind, I am in the PC and I'm sending the data down into the Arduino. And so you guys can get mad or argue or whatever you want, but that's just the way I look at it. I look at it as a download. Okay, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. All right, we got it working. Now, what on earth does that have to do with how do we pass data over to Python? Well, we pass it just by printing it. But as we print it and we're throwing it to the serial monitor, instead of opening up the serial monitor, Python is going to jump in and on that same COM port is going to catch it. Now, here's a pro tip, and this will make your life much easier if you learn this. If you have your serial monitor open, Python cannot go out and get the data because your serial monitor has locked up that COM port. So for this to work, you have to remember, make sure that your serial monitor is closed. Just a little pro tip there. Okay. So we are running here. Remember, it is still running while we're going about our business here. Now we need to go do some Python coding. So I need you to fire up the most excellent Visual Studio Code. And then we are going to come over here to this Explorer view. And then remember, we are working in the Pi Arduino. We're working in the Pi Arduino folder. And then what we're going to do is we're going to create a new program. And then that is going to be, let's call it pass data -1.py, and the .py is kind of important. All right, if you guys remember last week, in the last week's video, we already set up all of our libraries, and so our library should be there and ready to run. But the first thing that we're going to need to do is close this Explorer view. Okay, and then what I'm going to do is I'm going to import time because we might need to put a delay in here somewhere. So I'm going to go ahead and import time, and then I'm also going to import serial. Now, while we're calling it serial, it's really the Pi serial library that we installed last week, and then we're not getting in bad habits of putting semicolons on the end of commands in Python. That would be very bad, but easy enough to do. Okay, now what we need to do, this is really the core of what you're going to learn today. We're going to create a Python object, and that Python object is going to be the COM port. So we're going to set up an object that we can go and grab data from the object, and the object is going to be that COM port. And so we can name it whatever we want, but I'm going to name mine Arduino data because that's what it is. I'm going to get my data there, and that is going to be equal to serial dot, wait for it, serial with a uppercase s. That really bugs me. Import serial lowercase dot serial uppercase. Okay, and then what we got to do is we got to tell it what COM port we are on inside of single quotes. We were on COM3. Now notice, no space, COM3. If you're on COM5 on the Arduino, then it's COM5 here, but make sure that whatever this is the port that your Arduino is on. And now I got to give it the baud rate, and the baud rate has to match. So that was 115, 200, no comma. All right, now I have created an object that I can now read data from. All right, now this is also very key. It can take a little while, a small amount of time to initialize that, that COM port. And if you try to go read from it before it is set up, then you're going to get some very strange behavior. So you need to give it time to set up. And so just to be safe, I will say time.sleep, and I will wait 1 second. Now, if you're a guy who's interested in this type of thing, you could see like how low of a number I could use here and it would still work. I will tell you, sometimes you can put no delay at all and it might work, but putting a delay is really the way to make sure that it will work. Okay, now what we want to do is we want to constantly read the data. Now on Arduino, we've got that void loop that's always looping, but we don't have that on Python, so we need to create an infinite loop. And we'll say while, and while what? While true. Okay, when is true true? True is always true. So this will create an infinite loop. Okay. While true. I think that will work. I don't like that little squiggly underline there. I don't know why it keeps giving it to me. Do I have anything there? Okay, it's just going to be there. I don't know why it's there. Right now, what we have to do, we can't go out and just read that serial port because there might not be any data there. There might not be any data there. So what I need to do is I need to wait. So I'm going to say while, and this is just to wait. While what? While our Arduino data, that's that object I created, while Arduino data dot in waiting. Okay, Arduino data dot in waiting, open close, while that's equals 0. All right, so what does that mean? It goes to our object Arduino data, it looks to see if there's any data there waiting, and if there's data, then the amount of data is not going to be 0. If Arduino.inWaiting equals 0, that means there's what? There's no data. So what do we want to do? We just want to continue to loop. So then we're going to pass. So it's going to sit there and just keep looping until there's data. Then once there's data, what we have to do is we have to drop out of that while loop. We've got to drop out of the while loop because now we are ready to read. And so now I need a variable to read. So I'm going to call my variable data packet, like that, data packet, and that is equal to Arduino data, that's our object, dot what? Read line, like that, Arduino data. Why did it not like that? Arduino data. Did I misspell Arduino? I hope you guys were yelling at me, and now that one I did wrong too. It would work, but you just got to spell it the same way all the time, and it's preferable to spell it correctly. Okay, so we have Arduino data in waiting, Arduino data read line, and so now I actually have a data packet. And so the first thing that we can do is just try to print that data packet. So I'm going to say print data packet. And so the interesting thing will be here, just are we getting data? Okay, now we need to come back and look at our Arduino program. Okay, make sure there's no serial monitor. It looks like there is no serial monitor, so we're going to come back over here. And I think that we are ready to run this program. And then let's see what happens on the Python side. Now you got to know, all this time while we're sitting here chit-chatting and programming and having our coffee, Arduino has been passing data the whole time. But once we go out to that serial port, then we will start reading. Okay, so now we run it. And what's going to happen? Look at that. Boom, Shazam, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. Also, you can see when we went out and connected to the that COM port, it reset the Arduino. So Arduino was certainly up to a very high number of counting, but when we connected to it, it restarted the program, and then it started from 1. Why are we happy? We're happy because we're getting data from Arduino to Python. I think we should go back and start doing the double chest bump again. Leave a comment down below. Do you think we should be celebrating our small successes in programming with a double chest bump? I think so. Okay, we're happy, but why are we not happy? What is this B : nonsense, and what is this /r/n nonsense? Those two things we don't like. Okay, what is the B? The B is kind of getting down in the data structure that when Arduino sent it, that is specifying that it's being sent as bytes, okay? And then but when we're reading it, we're reading the B, and now that is kind of messing us up. So it's good that it's there as we read it, but now when we have it, we want to strip that B off of there, if that makes sense. And then we also don't like the /r/n. What is the /r/n? Well, on the Arduino side, remember we did a print and then a println. Well, that println will put the /r and the /n on the end of it. The /r is like a carriage return, and the /n is like a new line, and so that's what puts it to the new line when we do a println. And that's great, but we really don't want that as part of our data. So let's see if we can take care of those two little annoying things here. So I've got the print data. This time what I'm going to do is I'm going to come in and I am actually going to convert that from a byte to a string. And so I'm going to say now data packet is equal to the string value of data packet, and then I've got to give it a format. If I'm going to make it a string, what type of string? It needs to be a UTF-8, okay? I could make a whole video on what UTF-8 means, but just understand that when you throw something in Arduino to the COM port and then you grab it in Python, you got to put it as a string UTF-8, and now you'll start having something that looks more like data that you can really work with. So let's go ahead. We don't have to do anything on the Arduino side because the program is still running. The Arduino side, the program is still running. So we'll jump down here and run the Python side. Look at that. 1 Mississippi, 2 Mississippi, 3 Mississippi. Counting in Mississippis. All right. Okay. Now, what is one thing that we really don't like, though? Okay, what is one thing that we really don't like? And one thing that we really don't like is it's skipping 2 lines. Now, why is that? Because the data packet itself has that /r and /n, and then when I do a print in Python, that goes to the next line. So it's like we're going to the next line twice. And so how do we do that? What we want to do is we want to strip off that -r and that -n. Okay, and then what we can do is we can just get a nice clean data packet at that point. And so what we can do is I can come in and say data packet is equal to data packet, okay, and then what I want to do is a dot strip, and then what do I want to strip off? I want to strip off the /r/n, like that. I think that. Now I forgot. I need to take these 2 out. I got to make sure which direction those 2 were going. If it was the / or the /, and if I do this, we should be able to see it on there again. Okay, it is, yeah, that's right. I got it right. // Okay, so now this then should strip it off, and now when I print data packet, it should work. There it is. Okay, now you see no extra line because I got rid of that extra carriage return line ending. Now you really want that carriage return and line ending in there, because when I do a read, when I do a data packet equal Arduino data.readline, it reads until it finds that character. So when you send it from Arduino, you really want to do the print ln, so you end up with that /r/n. Okay, and then that tells you when to stop reading. But then you can see what our program here is doing. It's sitting and waiting for data. When there's data, it reads it. It reads it until it sees the /r/n. It reads it in, and then it takes that byte character off, and it takes the extra character return off, and then things work great. Okay, that is really good. Okay, let's see if we can do something a little bit more complicated. All right, let's see if we can do something a little bit more complicated. We're going to come back over to the Arduino side. Okay, and this time what we are going to do is, let's just say, instead of count, let's say that I have an x is equal to 1, and then let's have an int, and let's make it y is equal to 2, and then let's have a int, and let's have z is equal to 3. Okay, and then let's come down here, and then as we're going to keep our delays and keep other things the same here. And then what we're just going to do is on our incrementing, we're just going to get rid of all this stuff here. And then I'm just going to say x is equal to x plus 2. All right. And then I'm going to say y is equal to y plus 5. And then I'm going to say z is equal to z plus 4. I'm just trying to generate data, 4 different numbers, so kind of like 4 different channels of data. How would we send all of that data, kind of like a little bundle of data of 3 variables, x, y, and z? Well, what I would do is I would do serial.print, okay? I would do serial.print, and then what would I print? I would print x, okay? And then I would do serial.print, and I need to put a delimiter, a data delimiter, so I'm going to put a comma like that, okay? And you might have to use double quotes here, actually. We'll do that to be safe, okay? And now what am I going to do? I'm going to do a serial.print, and now I'm going to print y, okay? And now I'm going to do a serial.print, and then that is going to be another comma, a comma, okay. And then serial.print, and then z. Okay, now I don't need to, right? I don't need to put a comma after the z, because this will just be x comma y comma z, new line. And so it should read x comma y comma z and then a new line. But what we want to do here is we want to go ahead and run this on this side. And then what we want to do is we want to look on the serial monitor, just making sure that we're generating data like we would expect before we jump over to the Python side. So we're going to look here, and 377, oh, okay, what's wrong? That last one needed to be what? This one needed to be a what? Print ln to go to the next line, because Python would just keep reading, looking for that end line. It would never work. Okay, it would never find one, so it would just hang. So let's go ahead here and do it. Okay, let's read the serial monitor. Okay, so you see nice behaved data. We're passing chunks of data. We're passing chunks of data. All right, so now what would we want to do? We got to kill the serial monitor, but the program will keep running. Now, coming over here, now what do we want to do? Well, we still want to wait for the data. We still want to read it. We still want to strip off the byte business, convert it to a string. Then we want to take off that /r/n. Okay, now let's just run this. This should print, I mean, this should give us kind of like the 3 numbers over here like we had it over there, if I'm thinking about it right, is a good start. Okay, 377. Very good. Okay, what is the one problem that we have here? That is a what? That is a string. If we're going to play with those numbers, we need them to be numbers. And so how would we turn those things into numbers? Well, what we need to do is we need to come over here and we need to split. We need to say that the split packet, we need to split that packet and put it in a new variable. Split packet is going to be equal to data packet dot what? Split. We need to split it on what? Split it on the comma. All right. And we're going to use double quotes here. Okay, we're going to split it on the comma. All right, so what is this going to do? Split data is then going to be an array, and the array is going to have 3 values, and it's going to have the values based on, it's going to have the data based on what those 3 numbers are that we split, that we sent. Okay, so we split it, and now if we print split packet, it should print an array, if I'm thinking about this right. Okay, if I'm thinking about this right. All right, hopefully. Okay, boom. Now look at that. Now the one thing you got to see is it's passing an array, but it's passing 3 what? It's passing 3 strings. Okay, so you better keep that in mind, that you get one array and that one array has 3 strings. So what do we want to do at that point? Well, we want to go ahead and do something useful. So what we're going to say is x, our variable x, is equal to, we got to float it because it's a string, float of what? Float split packet, the first element is element 0. So we're taking the first element of the array, we're converting it to a float, and we're putting it in x. Okay, and now I think we can copy this, and then we can paste it, and then we can paste it, and then character return. And then this we will call Y, and then this we will call Z, right? And then this is split packet element 1 and split packet element 2. And now we're going to do a print. Okay, instead of print split packet, we're going to print what? We're going to print the string x equal, quote, x equal space, and then comma, what? X, and then comma, what? Y equal space, and then comma, what? Y, and then comma, and then quote, z equal space, comma, what? Comma, z. Okay, so we're going to print x equal x, y equal y, z equals z. So now let's run this thing and see if this actually works. Ah, okay, very good, except I got an extra. Put the end quote inside of that. Okay, and that should not be there. That should be x equal x. There, little minor formatting problem. Okay, let's run this thing. Okay, x is equal to 5, y is equal to something, z is equal to something. Okay, so that data that we're passing over, we grab it as a chunk, we clean it up, we split it, we convert it to floats, and now we have real numbers that we can actually do things with. Also, look, we went to floating point numbers. We started out with integers, we passed them as a string, and then we converted them to a float, and so now we are actually printing them out as a float. Okay, guys, man, this is pretty cool. We're writing programs in Arduino, we're passing the data to Python, and then we're grabbing it in Python and we're doing something with it. Okay, let's see if we can make it a little bit more interesting. And so for next week, what your homework is in your Elegoo, your most excellent Elegoo Super Starter Kit, I need you to get your little potentiometer out. And then what I want you to do is build a circuit with a potentiometer. I want you to take the potentiometer reading from that center leg, and then I want you to pass that over to Python, and then I want you to print it out in Python. And then as you are changing the data here on Arduino, I want that on the potentiometer, I want that to be reflected over in Python. Now for you guys that just know Arduino and really don't know a lot about Python yet, just print it, because I've shown you everything that you need to know in order to do that. And then for you guys that have taken my lessons on Visual Python, I want you to make a Visual Python graphic that will show visually the data about where your potentiometer is. Okay, now you could either maybe you could convert it to voltage, and then after converting it to voltage, you could display the voltage in Visual Python, or you could make some sort of little meter where you are showing the voltage based on where the position of the potentiometer is. Does that make sense? Okay, I hope it does. Now, for you guys that don't know how to do Visual Python, don't worry, because next week I will show you the solution to the homework. Based on what I've shown you here, you ought to be able to at least program up the potentiometer and pass the data over and print it in Python, and then you'll learn something when you see my solution. For you guys that have taken Visual Python, let's see just how slick of a demonstration, how slick of a visual you can make based on this assignment. Okay, you guys need to post your solutions to YouTube. For you guys that are new, what you do is you just do a screen capture of your program running, showing me what it does. Then you post it to YouTube under your YouTube account, and then down below in the comments, you leave a comment with a link over to your YouTube video, to your solution. And then also when you post it on YouTube, make sure that you leave a link back to this video so anybody watching your video would know what you're doing. They would have context. You link back to me, and then from the comments below, you link to your solution. I hope that makes sense. Okay, guys, I hope you're having as much fun with this class as I am. I am really looking forward to getting back into our Arduino hardware and linking up and getting Arduino working with Python. And so this is going to be a lot of fun. Again, this is Paul McWhorter from TopTechBoy.com, coming to you from the lovely shores of the mighty river Nile. I will talk to you guys later.